Alright, this is the second algebraic method to solving systems of equations. It's elimination, and this is usually more well-liked than substitution, so here goes. So in the first one, really the point is to line up your variables, and this is particularly nice to use elimination when you have both x and y on the same side of the equal sign for both equations. And what you see is the x's line up and the y's line up, but our goal here is to get the same variable to have the same number in front of it, but opposite signs. So as of right now, we kind of see that, you know, this top one has 7x plus 2y equals 0, and this guy says 5x minus y equals 17. So nothing lines up. They're not the same number. Yeah, we kind of have some opposite signs here, so that's kind of nice. And that's a 1 in front of the y. So what we want to do is we want to just change one of the equations to make the same number appear in front of one of the variables. And I can change this 1. It's a negative. I can change it into a 2 pretty easily just by multiplying it by 2. But I have to do that to everything in the equation, otherwise it's cheating. So this is going to be 2. I'm just going to times it to everything. I'm going to have the same original equation up there, 7x plus 2y equals 0. But now the bottom equation is now 10x, because I multiplied it by 2, negative 2y, because I multiplied it by 2, and 34, because I multiplied it by 2. The reason we wanted these two things to line up, the positive 2y and the negative 2y, is because we're just going to smash these two equations together. We're going to say, I'm just going to add everything together. The x's are going to go together, the y's are going to go together, and then the other side of the equal sign, they're going to go together. I'm going to add them all together. This becomes a 17x, and the beautiful thing that happens here, and that's why it's called the elimination method, is because we just eliminated the y variable, because the positive 2y and the negative 2y is 0. So now there's no more y's. And our resulting equation is, we just have 34 on the other side. So we see that we just have 17x equals 34, and that's a pretty basic equation to solve. Divide by 17, you get x is 2. The last step is the exact same as in substitution. You just substitute your x value, whatever it is, back into one of the original equations. So I'll choose the top one this time just for fun. It'll be 7 times 2 plus 2y equals 0, which is 14 plus 2y equals 0. But now it's a two-step equation. We got to get rid of this 14. Move to the other side. You get 2y equals negative 14. And your last step, you know, get y by itself by dividing by 2. So then y equals negative 7. So your answer here is 2, negative 7. So in general, elimination's a nicer way to go about it. So there's two more examples here. Take a look at this one. We want to try and either line up our x's or our y's, and we want them to be the same number in front of that one variable, not both, but same number in front of one variable, and opposite signs. So as you can tell right now, the x's have the same sign. It's easy to make the top 3x look like a 6x, you just multiply by 2. But really, it'd be easier to change the y's, because the y's are already opposite signs, which is what you want. So we're going to multiply the bottom one by 2, because that will give us a positive 4y on top and a negative 4y on the bottom equation. So 2 to everything. Then, you know, this equation, it's still fine, but I'm just going to cross it out because I'm not going to use it anymore. This is now going to be a 12x, negative 4y equals 6. I want to add these together, combining these equations, because the 4y and the negative 4, when I add them together, like terms, they disappear. It's now a 0y, or just nothing. 3x and 12x make a 15x. And then negative 1 and 6 make a 5. So 15x equals 5, divided by 15, divided by 15, and yeah, this is where a lot of people just start freaking out. You know, you get 5/15ths, you're like, oh, that's not going to work, I messed up somewhere. No, you just got a fraction, and it's all good. You have a 1/3. So we're halfway there. Just plug this in back into original equation. I know it's a fraction, but we gotta be able to handle that. 3 times 1/3 plus 4y equals -1. When you do fraction multiplication like this guy, you need to make them both fractions. And you'd end up with 3 over 3, which is just 1. So this whole term turns into 1. Plus 4y equals -1. And then this is all about just two-step equation. So subtract 1, subtract 1. 4y equals -2. Divide by 4. And y is -1/2. -2/4 you just, reduce. So 1/3 -1/2 is that solution. Oops. So the final example is a little bit uglier. Like, what if all this stuff doesn't match up? I mean, we got 2x and 5x in this one. Can't really multiply 2 by something to get 5. I mean, you can figure out something, but same with 9 and 4. So kind of an easy way out of this, or the only way out of it, is to multiply both equations by something. But keep in mind, they have to be opposite signs. Right now, both the x's are the same sign and the y's are the same sign. So I'm going to have to multiply one of the two equations by, a negative. And I like to keep my smaller numbers, so I'm going to deal with the x's this time. I want the x's to be the same number in front, and I want them to be opposite signs. So I'm going to say, how about I multiply the top by a -5? That would give me a -10x. The bottom equation I'll multiply by a 2. That will give me a positive 10x. So we'd have a -10x on top and a positive 10x on bottom. We would have done what we needed to then if that was the case. So -10x plus 45y equals positive 120. Bottom equation is 10x minus 8y equals 28. And everything's still good. We got to add down because our x's are already lined up and they're already the opposite sign, so that's good. So when we add down, those are gone. That's kind of the whole point. When we do the y's, we add down, we're going to get 37y equals 148. And then when you divide, you're going to get 4. So you get some bigger numbers there, and it kind of sucked, but it was all good. You can take any of these equations to plug y back into. I could take this one if I wanted, that one if I wanted, that one, or that one. So generally just try and choose the smallest numbers. I'm going to go with this guy. Looks like the smallest numbers. 5x minus 4 times 4 equals 14. This ends up being a 16, a negative 16. So we're adding 16 to both sides. You get 5x equals 30, and you divide by 5 to each side. So x is 6, y is 4, and that is elimination. Yay.